Today we're going to talk about creating solution. There's two different ways that we can create a solution. One is when you start with a pure solid solute, and you use water as your solvent. The second way is you start with a concentrated solution and then dilute it. Let's talk about starting with a pure solute first. So you're starting with your amount of grams of your solute, and you're going to put it into a certain quantity of water, which is going to be your solvent. When you put them together, they create your solution. Whenever we're doing that, we're going to have to use our molarity equation in order to figure out the concentration, which is the same thing as molarity, okay, of the solution we're going to create. So molarity is the moles of solute divided by the liters of solution. So let's do this example problem. It says, what volume of solution is needed to create a 4.00 molar solution when using 23.5 grams of NaCl? So we're solving for liters, so we should set up our equation as molarity is equal to moles over liters. Now we're solving for liters, but we don't really have moles either. But what we can do is we can convert our grams to moles using a conversion. So we're starting with 23.5 grams NaCl. We want to convert it. So we're going to go to 1 mole divided by the molar mass of NaCl. And just for a little reminder, in order to get your molar mass of NaCl, you have to add together the molar masses of both elements. So sodium is 22.99, chlorine's 35.45. So we end up with 58.44 grams. So when we do that math, we're going to end up with 0.402 moles NaCl. Now we have moles, we're already given molarity, so all we have to do is solve for liters. Now, liters is on the bottom, so we have to rearrange our equation a little bit. So we're going to multiply both sides by liters, move it over. So we have liters times molarity is equal to moles. And again, we're solving for liters, we need to divide both sides by molarity. So we have liters is equal to moles over molarity. We already solved for our moles divided by our molarity, which was given to us in the problem. We want to divide so when you divide, the answer you get is 0.10 liters of solution. Let's look at the other way. So in this way of making a solution, you have a concentrated solution that's already made. And what you're trying to do is you're trying to make a more dilute solution. So here we're going to use the molarity of the first solution times the volume of the first solution times the molarity of the second solution equals the molarity of the second solution times the volume of the second solution. So let's see how we would do a problem with that. It says what volume of concentrated solution, so it's telling us that the molarity of the concentrated solution is 11.0, would be needed to create 250 milliliters of a 1.5 molar solution. Now, when we're doing this kind of problem, it's not necessary to convert milliliters to liters. You just have to be aware that the volume that you will be solving for will be in milliliters. That is different than this problem because our equation includes the units of liters. You have to make sure that that is in liters. So here we can solve with it with milliliters. Now I think a good way to organize your work is to set up a little chart so you know what you have and you know what you're looking for. So molarity for your first solution tells you that it is an 11.0 molar solution. We want to know the volume of the concentrated solution. Your concentrated solution is always your first solution. That is what we will be solving for. The molarity of the dilute solution, so we're needed to create 250 milliliters of a 1.5 molar. That's going to be our second concentration. And we have 250 milliliters as our volume of our new solution. So we're solving for V1. So let's rearrange our equation so we get V1 by itself. These two are multiplied, so we can divide both sides by M1. So we're going to end up with V1 is equal to M2 V2 over M1. Now we can just plug in our variables. So M2, we have 1.5 molar. V2, we have 250 milliliters divided by the original concentration of 11.50 molar. Multiply this on top and then divide through. And you're going to get, you need 34 milliliters of a concentrated solution in order to create your dilute solution.